This is the second part of the review for the second exam in COMP360 Programming Languages at North Carolina A&T State University. The second exam is on Friday, March 27 from 2 o'clock to 3 o'clock. You must be online on Blackboard at those times to take the exam. Start at 2 because the exam will end at 3. The exam will include all material we've covered since the first exam. In particular, it will cover parameter passing paradigms, garbage collection, tail recursion, generics, and object-oriented programming concepts such as constructors, overloading, overriding, and polymorphism. We're going to be using a language that I invented for the exam called ExamGault. ExamGault works exactly like Java. So anytime you wonder how does this work, it works just like Java. Except the syntax is significantly different. No semicolons, no curly brackets. It uses indenting to determine the nesting level, very much like Python. Constructor methods do not have the same name as the class name. Instead, they just have the name constructor. Functions start with the word function. Here's an example of ExamGault and Java for the same program. You can see instead of saying extends, ExamGault inherits from. The type of a variable is declared after the variable name with a colon. And that includes parameters. After that, it's pretty much like Java, except the syntax is different. No semicolons. You're going to have to read and understand ExamGault to pass the exam. You will not have to write any ExamGault programs. In Java and ExamGault, one constructor can call another constructor. In this example, there are two constructors, one with no parameters, sometimes called the default constructor, and the other constructor takes a string parameter. So in the first example, when you create a new worm object passing it a string, it calls the string parameter constructor, which prints out the word fish and then returns. The second version, where it creates inch with a call to the default worm parameter, it calls the worm constructor with no parameters and prints, and then calls default to the other string. In other words, default is passed as dirt and it prints dirt, so it'll print default. Here's a more complex question. Okay, programs start in the main because programs always start in the main, and it calls BAS with no constructor, no parameters. So it goes up here and calls the BAS constructor. BAS then, because it extends fish, will by default have a super in here, and so it calls the fish constructor with no parameters. So it goes up here and calls fish. Fish then calls this with the parameter fish, so that goes down and calls fish. So that will print minnow. Now the fish is passed the parameter to minnow, so it's going to print fish. String printout will be fish, and then that returns, and it will print trout. And then that method returns back to the BAS one, where it'll print bass. So it'll print fish, trout, bass, which is answer D. In this program, we have the class child, which extends parent. Up in the main program, we create an object of the class child. So it calls the child constructor of the child class. This one does not have a call to super, so we can assume that there's an implicit call to super with no parameters. Since the parent is the parent of a child, it calls the parent class with no parameters, which prints the word parent and returns. And when it returns, it comes back to the child constructor, which prints the word child. So it will display parent child. Overriding a method is when a child class creates a method with the same name and same type of parameters. In other words, the header is exactly the same as the parent class's header. When you do this, then the child class will be used if you create an object of the child class and will not use the parent class method. In this example, we have a parent class called plant, and it has a method branch. Then we have the tree class, which extends or inherits from the plant class, and it also has a branch method. And both methods have exactly the same signature. That is, they are both void branch methods that take a one double parameter. When you execute this, and it starts down in the main program, you create a tree object called pine. And then we call the branch method on that tree object, passing it an integer. Well, there is no integer parameter method called branch. So Java will extend the 2 to a double. Let's convert the 2 to a double and call the child class. So it'll call the tree and it'll print tree 2.0. It calls the child because given that both are the same, it will always call the child on an override situation. And then when you call it with a 7.0, of course, it again calls the child class, because if you have a child class that overrides the parent class, then it always calls the child class. Overloading is different than overriding. Overloading is when you create a method with the same name, but a different type or a different number of parameters. Therefore, when you call that method, Java selects the parent or the child class depending on which one has the correct parameter types. If they both have exactly the same parameter types, then it's overriding and will always use the child class's method. In this example, again, we have the plant class and with the branch method, and the tree, which extends plant, with the branch method. But now the tree method has an int parameter instead of a double. So the parent class has a double and the child class has an int. Down in the main method, we create a tree object we then call branch, passing an int parameter, the integer 2. Since there's an int method, it will call the child class that takes an int. Cal becomes 2 and it will print tree 2. Then we call the method with 7.0, which is a double. There is a double parameter version of branch, so it calls the plant version and it will print plant 7.0. This is an example of different polymorphism from what we saw in the previous slide. This is subtype polymorphism, where a child class, in this case two child classes, extend or override the method of the parent class. And then we have another method that calls that parent class, and that Java has to determine which of the 2 or 3 methods you're going to call. So in this example, program starts over here. We create a tree object and a branch object, and then we call the let's here, passing it the tree object. So it goes up to the let's here method, and let's here takes a parameter animal. Well, both tree and branch extend animals, so both pine and puppy, which are tree and branch objects, can be passed to the let's here method because both tree and branch are animal objects. And then it calls goat.talk. Well, which one is it going to use? Well, if you pass it a tree object, then it will use the tree method, and the tree method prints meow. When you pass it the puppy object, which is a branch, the branch will then use that one called woof. So dynamically at runtime, Java has to decide which of the methods to call. It could call the animal talk method, the tree talk method or the branch talk method. It uses the one based on the particular animal involved, or excuse me, the particular class involved. Tail recursion is a particularly efficient form of recursion. Recursion is when a method calls itself. And in this case, the example, there are 3 return statements and the method calls itself at 2 different points. But every time the recursive call is made, it's on a return statement. Therefore, the returned value from the recursive call will be the returned value from the method. This is efficient because the method doesn't have to do any processing. When it returns, it just has to return at a deeper level. In this particular example, you can imagine that the compiler has converted it to this format, where instead of making recursive calls, it simply changes the local parameters, the parameters, and goes up and redoes the method. Calling a method has significant overhead. You have to push the parameters on the stack, use stack space, do the call, push the return address, create the activation record, and all those things, which you don't have to do if you just iterate. Although the user would write this as you saw in the recursive form, the compiler will compile it as if it was written like this. Therefore, it's significantly more efficient because it doesn't have to do all the overhead of an actual method call. My tail is pretty efficient. If you are writing a recursive method, it is always best to use tail recursion whenever possible. At one time, Java did not have generics, and so certain classes, such as ArrayList and hash map and other of the collection classes, took parameters that were objects and returned parameters that were objects of the class object. Therefore, whenever you returned a value, you had to cast it to the proper value. Of course, in this way, you could have an array list of any sort of objects. Since in Java, all objects inherit from the parent object, that if you have a class that takes a parameter of the class object with the big O, then it can take any class. If it returns a class that's an object with the big O, then it can be anything as long as you cast it to the proper type. Of course, you could always make a mistake casting. Generics change this by allowing you to specify what type of object will be in the array list. Here you can see the brackets and the class. In other words, array list is going to contain widgets and only widgets. So you can put widgets in, and when you get an object from it, Java knows that it's going to be of the class widget. You don't have to cast it because only widgets can go in, only widgets can come out. There are advantages and disadvantages to this. The advantage of using objects is that you can put array lists of anything. In other words, you can have an array list that contains widgets and thingamajigs and all sorts of objects. The disadvantage, of course, is that Java doesn't know what type of object is going to be put in and what type of object is going to be returned. You'll always have to cast the object that comes out, and you better cast it correctly or you're going to get an error. And of course, you can always make mistakes that aren't detected. So the big advantage of generics is it knows what type of type it's coming. Of course, with a generic, you can only put one type of object into the collection. Fortunately, in practice, this is what happens most of the time. Java knows what type is going in, and therefore it knows what type is coming out. Whenever you get an object from that collection class, it knows what type the object will be. Generics are actually only in the compiler. There's nothing that you have to change in the underlying method. The compiler just keeps track of what type of object is going in and knows that if you put a particular type in, then that particular type of object will be coming out. And so you don't have to cast it. It knows what it can expect. Okay, remember the second exam is this Friday, March 27th from 2 to 3 o'clock. You have to be logged on to Blackboard at that time. Contact old Dr. Williams if you have any questions. Good luck on your exams.